All right, we are verifying and proving that the left-hand side over here equals the right-hand side. And our objective and outcome is to try and get this sine squared theta. So what can we do on this side to make it look like that side? Well, we kind of want to have a sine squared theta all over the place. Well, luckily we got one up here on the top left. We got sine squared theta. So we kind of know already that we want to kind of get rid of this 1 minus secant squared theta and the tangent squared theta. We want to get rid of those and leave that sine squared theta, so we kind of get to this particular destination right there on the right hand side. So we're going to use Pythagorean identities in addition to breaking it up into sines over cosines, and breaking it up that way and manipulating it with conventional algebraic patterns. So let's begin this. Let's start off by, first of all, what we want to do is kind of eliminate this 1 minus secant squared theta. So the way to do that is go to the Pythagorean identities. And that would be the one like this. Now we probably know this one, where we have 1 plus tan squared theta equals secant squared theta. And what we're going to do is we're going to manipulate this so it kind of fits in here, but there's a bit of a challenge here because we've got a negative sign in the wrong place. We've got 1 take away secant squared. So how do we make that match up? So one of the best ways that we can do is swap the tangent with the secant. Swap them around. The signs will change on both of them. So that means we're going to have 1, and if I bring in the secant over to this side, it'll become negative because it's positive there, negative secant squared theta. And then take the tangent over that side, that's going to change sign too, and that's going to be negative tan squared theta. Can you see that? So now we have that to replace that right over there. So let's go ahead and do that. But first I'm going to write out the top again as it is. So we've got on the top, we have sine squared theta, take away tan squared theta, all over. Let's drag and drop 1 minus secant that and replace it with negative tan squared theta. So let's go ahead and put it right here. Negative tan squared theta. Okay, so we got that. Now, what do we want to do? Well, let's take the tan squared theta and put it underneath that one, because that's going to kind of help, and then put it under this one over here. So that's conventional algebra here. So let's go ahead and do that. So this will become sine squared theta all over negative tan squared theta. And now we've got here, we have minus tan squared theta all over a minus tan squared theta. As you can see, we've got two minuses. That's going to turn into a plus. So tan squared divided by tan squared, and they're both negative, that's going to turn into a what? It's going to be a plus 1 here, isn't it? So now how do we do this part over here? Well, we're going to break it up into sines and cosines and work that out. So let's do that. So we've got here sine squared theta, and what we want to do is divide that by another sine squared theta all over cosine squared theta, don't we? We want to do that. So how do we do that? Well, why don't we turn this upside down and multiply by it? So I'm going to go over there and work that out. So we've got sine squared theta over 1. Multiply that. Well, we turn this upside down, don't we? Because we know that tangent theta over here, tangent theta equals sine over cosine. So therefore, I'm going to take these guys, flip them upside down, and multiply by that. That way it's the same as dividing. So let's do that. So there's our sine squared again. That's what I wrote just before. So let's take these guys, turn them upside down, and multiply by them. So if I turn it upside down, it'll become cosine squared theta all over sine squared theta. So that's all flipped. And of course, we're going to have the negative sign there on it. So let's just put the negative sign there. So let's multiply that out. We can do some cancelling. So that cancels this sine squared theta on the top, and on the bottom cancels. That becomes negative 1. That becomes 1. So we're left with cosine squared theta divided by negative 1, which is basically negative cosine squared theta. So that's what we get from that. So let's bring that back down over here. So this part here, right there, becomes negative cosine squared theta over there. So let's write it over here. So we end up getting equaling negative cosine squared theta. All of that becomes this over here. And then we have this plus 1 over here. So let's get the plus 1. So we have plus 1. Negative cosine squared theta plus 1. Let me just write it out the other way and write it like this. Just rearrange it a little bit so it looks neater. 1 take away cosine squared theta. Now we know from Pythagorean identities what that is, because we know that sine squared theta plus cosine squared theta equals 1. Therefore, take the cosine on that side. So that means we have sine squared theta equals 1 minus cosine squared theta. So that's what this is. So we can replace all of that with that, which means we get right-hand side sine squared theta. That there is that there. And of course, this matches the right-hand side, which is sine squared theta over here. We have a match. Hope that helps.